one, Wednesday the 25th. So if you look at your packet, you go all the way to the end, the last thing in it, a little further. There we go. Is study guide for test number 1. Okay. The last thing in your packet. Sorry, the pages aren't numbered, but study guide for test 1, and there's a list of all the things you should be able to do going into the test. And then there's a resources that you can use to help you prepare, a list of resources. There's practice problems up in my math lab. Go over old homework assignments and quizzes. Look at the sample test, which is on the next page, and create a 1-page front and back reference sheet to bring with you to the test. So the only restrictions on the reference sheet are that it can normal size piece of paper, 8.5 by 11. You can write on both sides. You can write or type, but you have to create that sheet. Okay? No photocopies of somebody else's sheet. Question? According to the schedule, you won't be getting quiz 2 back, but I will grade it like the day you hand it in, so you could pick it up like at the end of the day, like by 4 o'clock or something. I'll have them graded, so you could pick it up at the end of Monday or on Tuesday, so you'll have it before the test. Okay, so yeah, test. Now the next thing after this page with the list of resources is sample problems for the test. And there are like 13 sample problems, and these are to give you like just a sense of what the questions will feel like on the test. As you're going through these, if you have any questions or there are any you can't figure out, if you go to our Moodle site, let me just get in there. In our Moodle site, there's a link to a playlist in YouTube that has either Ian or I or Linda solving all of the problems in the sample test in a video. So I'll just pull that up and you can see it. So scroll down, scroll down. If you didn't know, there's also a link to all of the class videos like I'm recording right now. And down under test prep material, there are sample test 1 solutions videos. So you click that, takes you to YouTube, and there's a video for each problem in that study guide. And then also, I made this thing, test 1 equation summary. I'll print it out and give it to you when the test gets a little closer. But it's there, and it should help you organize how to solve all the different types of equations that will be on the test. So maybe this could be one side of your 1-page reference sheet. Right? All the different kinds of equations, write yourself some notes, and maybe do an example for yourself. This is all in Moodle, yeah. So those are resources for the test. The test is still a week away, okay, but just to get you prepped so you know where everything is when you decide to start studying. All right, any questions about upcoming schedule kinds of things? Okay, I'm gonna have you skip the preview exercises because today's demo is a little bit longer than I anticipated. So we're just going to jump right to the demo. You can go back if you have time after. Okay, so here's a new definition. You may or may not have ever heard of this, depending on what math classes you've taken in the past. But there's one rule that we've been following so far in the class, and that's that you can't take the square root of a negative number. Okay. But we're just going to say, what if you could? Right? What if you could? And we're going to define the square root of -1. We're just going to say that is a value, and we're going to call it I. Square root of negative 1 is just a letter, we'll call it the letter I. So if k is some positive real number, if you want to take the square root of negative k, break it into the square root of negative 1 times the square root of k, and then rewrite the square root of negative 1 as an I. So quick example. Square root of negative 49. I would rewrite that as the square root of negative 1 times 49. Right? True? Okay, and then break that into two square roots, negative 1, square root of negative 1 times the square root of 49. That's allowed. Okay, as long as those two things are just separated by multiplication, you can do the two things separately. The square root of negative 1 simplifies to I, and the square root of 49 is 7. And then you could leave it like that, but that feels a little weird. And I would just swap the order because you can do multiplication in either order. So you get 7i. All right, square root of negative 8. So I would rewrite that as the square root of negative 1 times positive 8. Break that into two square roots. Square root of negative 1 is I. What's the square root of 8? It doesn't have a integer square root, but how could I? 2 square roots of 2. Do you guys remember how to do that? You rewrite the 8 as any perfect square number times something, right? You want to see if it has a perfect square factor. 8 happens to reduce to 4 times 2. And 4 you can take the square root of. You get 2. So this is going to be I times 2 times the square root of 2. Right? Because the square root of the 4 became a 2, and the square root of 2 stays. And then I would probably just rewrite this as 2i square roots of 2. Again, the order doesn't matter. It's just a personal preference to not have the variable come first. Although I is not a variable in this case, but it's a number, square root of negative 1. Okay, I squared. Okay. Yeah.
Because I equals negative.
Uh-huh. Okay. So I squared. I'm going to replace the I in this expression with a square root of negative 1. What do you get when you square a square root? You just get the thing, right? Squaring and square rooting undo each other. So if you have a square root and you square it, you just get the thing in there. So I squared is negative 1. All right, this little fact is going to be important. We're going to use the fact that I squared equals negative 1 a lot. Oh, good question. All right, so I cubed, I'm going to use a rule of exponents. That when you multiply like exponents, you like bases, you add the exponents, right? So I can rewrite I cubed as I squared times I. But what is I squared? Negative 1, we just figured that, times I. Negative 1 times I is negative I. I know. They definitely take some getting used to. Negative square root of negative 1. Yeah. I know. That's why we call it I and not the square root of negative 1. How about I to the 4th? Be 1. Because I to the 4th is I squared squared, right? Which is negative 1 squared. Negative 1 squared is negative 1 times negative 1, which is 1.
I'm sorry, can you remember how I squared?
Sure. So I squared, the definition of I is the square root of negative 1. So I'm taking, instead of I squared, I'm going to do the square root of -1 squared. Okay. And squaring and square roots, those are inverse operations. They undo each other. So if I take the square root of -1, whatever I get, when I square it, I'm going to get the -1 back because they undo each other. Mm-hmm. All right, good, good, good. Um, the I's are super confusing, as is the question of existence. Do I really exist? I don't know. Does a square root of a negative number really exist? We're gonna say it does. We just decided it does. We're gonna call it I. All right. So we refer to I, anything with an I in it, as an imaginary number. Should have written that earlier. So we call these things that have I's in them imaginary numbers. All right, a complex number is a number that looks like A plus BI. A and B are real numbers, so some examples would be 2 plus 5i, 3 minus 4i, 5 plus 0i, 0 minus 7i. Okay, it's got a real part, just a plain old regular real number, and an imaginary part, which is a number that has an I in it. Okay. And it's a sum of a real and an imaginary piece. So complex numbers are made up of real numbers and imaginary numbers. And we can do arithmetic with complex numbers. We can add, subtract, multiply, and divide the same way we do algebraic expressions. We just have to remember that I squared equals -1. So treat I like a variable, but anytime you see it being squared, replace it with a -1. So if I want to do 2 plus 3i plus 1 plus 5i, just treat that I like it were an x, like it were a variable, right? And you combine your like terms. So you add your 2 and your 1 and you get 3. 3i plus 5i makes 8i. So addition is just like as though it were a variable. Same with subtraction. You just have to remember to distribute that negative sign. So this is going to be 2 plus 3i minus 1 minus 5i. Then combine your like terms. 2 minus 1 is 1. 3i minus 5i is -2i. And then for multiplication, you just use the distributive property. Or some of you might have learned the trick called FOIL, right? Just that's all you do, yeah. So you have 2 times 1 is 2. 2 times 5i is 10i. 3i times 1 is 3i. And 3i times 5i is 15i squared. Combine your like terms in the middle. 10i and 3i make 13i. And then I have an I squared. What does I squared equal? -1. So replace that I squared with a -1. And 15 times -1 is -15. So this is 2 minus 15 is -13 plus 13i. -13, because I combined my like terms with the 2 and the -15. Yeah. All right, let's look at E here. It's the same kind of thing. We're just going to multiply again. So I do my first, I get 2 times 2 and I get 4. Then 2 times -3i is -6i. 3i times 2 is +6i. 3i times -3i is -9i squared. And when I combine my like terms, I have a -6i and a +6i. So those cancel, because they just add up to 0. But I have a 9i squared, and I squared is really -1. So this is 4 minus 9 times -1. What does that simplify to? 13. So something special happened in that last one. I multiplied 2 plus 3i and 2 minus 3i, and I got a real number, like a plain old number. And you're like, oh, my old friends, those numbers that don't have i's in them, right? So that happened because 2 plus 3i and 2 minus 3i are called conjugates of each other. The conjugate of a complex number a plus bi is a minus bi, and the conjugate of a minus bi is a plus bi. So for example, the conjugate of 2 plus 3i is 2 minus 3i. It might be helpful if you have a shortcut for multiplying conjugates together. So if I want to multiply a plus bi and a minus bi, I do my distributing and I have a squared, right? Minus abi plus abi minus b squared I squared. And then the ABI's cancel, and you end up with a squared. The I squared is really -1, so it's plus b squared. And that's what we got when we did 2 plus 3i and 2 minus 3i. We got 4 plus 9 was 13. You don't have to memorize this. You can just multiply them out every time. I do. All right, one last thing about complex numbers, and then we're going to go into why the heck are we talking about this, right? They actually end up becoming solutions to certain kinds of equations. All right, if a radicand is negative, radicand just means the thing under a square root, thing under a radical. If it's negative, write it in terms of I before you do any operations, right? So radical -20, that would be I radical 20. Pull out the negative first. Then multiply by I radical 5. Right? So simplify by taking the negative out of the radical and making it an I first. Then this is all multiplication. We can multiply it all together. So we have I times I is I squared. And all multiplication, so I can multiply the things under the radicals. 20 times 5 is 100. I squared is -1. And radical 100 is 10. So I get -10. Whoa. All right, so that was kind of like a crash course in imaginary and complex numbers. Just sort of like what you need to know to be able to do what we're going to do next. Okay, so if any of this is like hazy, just stop me in the next thing and say, you know, I don't get whatever you just did with those complex numbers. Okay. All right, so we're going to talk about quadratic equations. Now this, I'm pretty sure that you will have seen before, okay? Linear equations are first degree equations. They look like this: 2x plus 1 equals 5, 4 minus 3x equals 2. You've probably spent a long time, a lot of course time learning how to solve these things. Quadratic equations are second degree equations, which means they have exponents of 2 somewhere in them. Okay. So the general form of a quadratic equation is ax squared plus bx plus c equals 0. And a, b, and c just represent some numbers. We're very familiar with techniques used to solve linear equations. You've been doing that for a long time. Some ways to solve quadratic equations we're going to look at next. So our first technique is if you can make it look like x squared equals some stuff, or some stuff squared equals a number. Right? If you can make it look like some stuff squared equals a number, then you can solve them just by taking the square root of both sides. Right? So if x squared equals -25, you just square root, square root. What is the square root of x squared? Sort of. Negative and positive, yeah. So it's actually, all right, let's do a little aside here. if I have x and the square root of x squared, right? Somebody pick a value for x. 1. Okay. So if I plug a 1 in here, square the 1 first, and you get 1. Square root of 1 is 1. Somebody give me another x. -1. Okay, if I put a -1 in here, -1 squared is 1, and then the square root of 1 is 1, right? So you don't always get the x back. You actually get the absolute value of x. It'll always give you the positive. So you have to know that when you're doing this and say the square root of x squared, it's x, but it could have been the negative of that. So maybe we could put a plus or minus. If it's cubed, you don't have to worry about that. Or I mean, if it's a cube root, you don't have to, but the squaring is what sort of got rid of that negative sign. Yeah. What's the square root of -25? 5i. 5i. And I've got the plus or minus over here. I'm just going to move it plus or minus 5i. Square root of both sides. Okay. So we had this equation that before today we would have said it had no solutions, right? We would have said there is no number that when you square it you can get -25. But we just invented one. We're going to call it 5i. That's the number that when you square it you get -25. Okay, slightly more complicated one. First thing I need to do is make it look like some stuff squared equals a number. So I'm going to get rid of that -2. Divide both sides by -2. So I have x minus 7 squared equals 10. So now I've got some stuff squared equal to a number. And how do you undo squaring? Square root. Oh, I could, yeah, but I'm going to do that technique later. I've got some stuff squared, so to undo the squaring, square root. Square root of x minus 7 squared? X minus 7, yeah. Sort of, right? We just need to put the plus or minus on the other side. Yeah. Plus or minus radical 10. Then how do I finish getting the x by itself? Just add 7. Plus 7, and we end up with x is 7 plus or minus the square root of 10. And that's what we call an exact answer, because radical 10 is one of those irrational numbers whose decimal goes on forever, no repeating. So as soon as you stop writing numbers, you've rounded it. So if you wanted to write this as a decimal, that would be an approximate solution. But this one is exact. Let's open a calculator and get an approximate. Okay, so I have to do 7 plus the square root of 10. And I get 10.16. And 7 minus the square root of 10. Because it's plus or minus, so I get 3.84. And I use the squiggly line to indicate that these are approximate solutions. So be careful, pay attention when you're reading directions, either in my math lab or on a quiz or a test. If it asks for an exact answer, that means just leave the radical in it. If it asks for an approximate answer, that means type it into your calculator and give a decimal. Exact is the top one, approximate is the bottom one. Okay. There'll be directions on how to round on anything that I give you. Yeah. In the absence of directions, do hundredths. Yeah. My rule of thumb. Okay. Another technique for how to solve quadratics. This involves factoring. Okay, so factoring is a technique that you probably struggled with a lot in a previous course. We're going to continue the struggle when we're solving quadratic equations. Okay, so here's the zero product property. If you multiply two numbers together and the answer is 0, the only way to get 0 as the answer to a multiplication problem is if one of the factors was 0. Okay? So I'm going to exploit this fact that if I can multiply two numbers and get an answer of 0, I know one of the two has to be 0, or both, right? So I'm going to solve this quadratic equation by factoring. So first thing, the zero product property is only helpful if one side of my equation is 0. So I'm going to start by moving the 24 over. So I have x squared plus 11x plus 24 is 0. Okay, so x squared plus 11x plus 24, can anybody factor it?
6 and
8 and 3. What made you give up on the 6 and 4?
6 times 4. 6 plus 4.
Right. 6 and 4 do multiply to 24, but they don't add to 11. Yeah. So what you're looking for, at least in the case when the coefficient on the x squared is a 1, you're looking for numbers that multiply to make 24 and add to make 11. So you start mentally listing factors of 24, and you go 6 and 4, add them, nope, those make 10. 8 and 3, add them, yeah, those make 11. So it's got to be 8 and 3. X plus 8, x plus 3. There are lots of techniques for factoring. I am just a trial and error kind of person, right? I might have just written down the 6 and the 4, multiplied them back together and gone, no, didn't work, try a different set of factors. So anyways, factoring will come up, but we'll face that as it presents itself. All right, so now I have written a multiplication problem. I have x plus 8 times, right? There's no symbol there, but that means times x plus 3, and I get an answer of 0. So I'm multiplying two things together. The answer is 0. The only way that can be true is if either x plus 8 is 0 or x plus 3 is 0. One of and/or, right? One of those two things has to be 0. So we get x equals -8 and x equals -3, and those are our two solutions. Either of those will make the equation true. Yes. Yeah, that's the next technique, and we're going to do that next. Yeah. All right, third method for solving a quadratic equation. It's generally the most useful method because you can use it no matter what the quadratic equation looks like. Right? If you put it into this form, ax squared plus bx plus c equals 0, we have a formula where you can just plug in the a's, b's, and c's into this guy, and it will tell you the solutions. So we get -b plus or minus the square root of b squared minus 4ac all over 2a. You can sing it to Pop Goes the Weasel. I'm going to skip it. Maybe next time. Okay. So we're going to solve this guy with the quadratic formula. So first I need to write out what are a, b, and c. What is a in this quadratic equation? 1. That's the coefficient on x squared. There's an imaginary little 1 there. What's the coefficient on x? -6, and the constant term? -7. So there's my a, b, and c. And then I plug into the quadratic formula. So my b is -6. So what is -b? 6, yeah. So you might read this, instead of -b, you might read that as the opposite of b. Because if b is already negative, then that sign means make it positive. Okay, b squared. What is -6 squared? 36, because -6 squared means -6 times -6, which is positive 36. Okay, then we have 4. A is 1, C is -7, all over 2 times 1. So we get x equals 6 plus or minus. I'm going to simplify all this stuff that's under the square root. I've got a -4. I'll keep the 36 for now. Got a minus sign here and a minus sign here. Negative times a negative will give me a positive. So that becomes a plus 28 all over 2. So x is 6 plus or minus 36 plus 28 is 64. Yeah. Okay. All over 2. What's the square root of 64? 8. So I get x is 6 plus or minus 8 all over 2. So first do the plus. What's 6 plus 8? 14 over 2 is 7. And 6 minus 8, negative 2 over 2 is negative 1. So there's my two solutions. So the whole thing with complex numbers, why we talked about the complex numbers first, is that they are sometimes solutions to quadratic equations. Like with our first example when we got plus or minus 5i. Sometimes you get a negative under a square root and you get a complex number as your solution. So I did first, because this says plus or minus, right? So first I did the plus. 6 plus 8 is 14, over 2 is 7. And then I did the minus. 6 minus 8 is negative 2, over 2 is negative 1. Yep. All right, so that was a bit longer for the demo part than usual, but you still have plenty of time to work through some of these activities.